06:17 local time, 5 Ukrainian Barracuda drone boats slipped into the Dnepro River outside Kherson, heading toward a Russian small boat forward operating base, packed with fuel drums, ammunition crates, and engine parts. But before the Barracuda could reach its target, it had to survive. Something even more dangerous than Russian defenses, the Barracuda cleared the last reeds on the Ukrainian bank and entered open water. Immediately, a Ukrainian machine gun positioned 500 feet upriver swung its barrel toward the heat signature. The Barracuda operator, sitting in a hardened bunker 14 miles away, froze his controls. The Barracuda drifted on momentum alone. Overhead, a Ukrainian FPV quadcopter circled at 1,000 feet, broadcasting a coded friendly signal, while the gunner below raised his night vision goggles and scanned for the one thing that would keep him from pulling the trigger. 5 seconds. 7, then he saw it. A pulsing infrared strobe on the Barracuda's hull, blinking a pattern only Ukrainian forces would recognize. For a brief few moments, everyone stood still as the Ukrainian gunner watched through his night vision goggles. Any miscalculation now and the mission is over before it starts. Thankfully, he paid attention to his pre-watch turnover brief and lowers his weapon. The Barracuda had just survived its first threat, and this problem is much more common than you think. If you look at the Barracuda itself, you'll understand why it's so easy to mistake for an enemy vessel. The hull is 18 feet of fiberglass composite light, enough to plane at high speed, tough enough to absorb small arms impacts without catastrophic failure. It rides just 16 inches above the waterline on a modified deep V hull that cuts through river chop while keeping radar cross-section to a minimum. The propulsion system is a single 20-watt brushless electric motor fed by lithium batteries with a 4-hour endurance at patrol speed. At 8 knots, the motor is nearly silent. You won't hear it until it's within 200 feet. At full sprint, the same motor pushes the boat to 30. 8 knots, fast enough to outrun any manned vessel the Russians have on the Dnepro. In the bow sits a 35-kilogram shaped charged warhead, enough explosive to gut a patrol boat or today detonate a fuel depot. And if the control link ever fails completely, the onboard GPS autopilot can execute a final waypoint attack. Autonomously, the Russians aren't just facing a remote-controlled boat, they're facing a boat that can finish the mission alone. That's why thermal identification is so crucial. A Ukrainian soldier scanning the river at night sees a bright streak moving fast and low. He has maybe 3 seconds to decide if it's friendly before it passes his position. If he guesses wrong and hesitates, a Russian boat gets through. If he guesses wrong and fires, he destroys his own mission. That's why Ukrainian outposts receive detailed corridor briefings at every watch. Turnover, they're told exactly which lane a friendly drone will transit, what time window to expect it, and what identification signal to look for. If you look here on the Barracuda's deck, you'll see a small device about the size of a hockey puck. This is an infrared beacon invisible to the naked eye, but through night vision goggles, it pulses a specific pattern different from what the Russians are using that tells any Ukrainian gunner, hold your fire. The gunner doesn't need to. Break radio silence or expose his position with a spotlight. He just checks his NVGs, confirms the strobe code, and watches the boat pass. But the infrared strobe alone isn't enough. The Barracuda was crawling at just 8 knots through the friendly zone because behavior is the final confirmation. At this speed, the boat's wake stays flat, a thin controlled ripple that looks deliberate, not evasive. Russian sabotage boats sprint and zigzag because they're trying not to get shot. Ukrainian drone boats move slow and straight because predictable movement matches the briefing. 3 checks have to pass: the right corridor, right strobe, code, right behavior. Only then does the gunner hold fire. The Barracuda cleared the final checkpoint and entered the transition channel, sliding past the last Ukrainian positions as it did so. But while Ukrainian gunners can hold their fire, this other Ukrainian system cannot. The Barracuda pushed to 14 knots as it entered the mid-river channel. The FPV drone climbed to 1,300 feet to widen its view, then the video feed on the operator's screen flickered. A single frame froze, stuttered, then jumped forward. Something was interfering with the signal, but it wasn't, coming from the Russian side. Every night, Ukrainian electronic warfare units blast the river corridor with radio noise designed to disable Russian drones before they reach friendly positions. The jamming doesn't distinguish between enemy signals and friendly ones. This is because the front line is so saturated with drones. Neither side risks having electromagnetic corridors. It just takes one enemy drone to find it by accident, and all of a sudden you've got hundreds of drones in your face. That's why both sides flood the airwaves and let the operators sort out the mess later. This creates a serious problem for the Barracuda because the drone boat doesn't receive commands directly from the operator's bunker. The distance is too far and the terrain is too cluttered. Radio signals travel in straight lines. But the Dnepro riverbank is a maze of reeds, sandbars, flooded forests that block, scatter, and absorb transmissions. A direct signal from the bunker would fade out within 3 miles. So Ukraine uses a relay system. The operator's commands travel through a fiber optic cable to a hidden transmitter site 8 miles behind the front line. That transmitter fires a tightly focused radio beam only 4 degrees wide, directly at the FPV drone overhead. And that drone is purpose-built for this mission. If you look at the quadcopter circling above the Barracuda, you'll see a heavily modified DJI Matrix 300, a commercial platform the Ukrainians have transformed into a battlefield relay station. The stock version carries cameras and sensors for industrial inspection. This version carries a 15-watt signal repeater, a directional antenna array, and a thermal imager refreshing at 60 frames per second. The Matrice's original 55-minute flight time has been reduced to 38 minutes because of extra payload weight, but that's still enough endurance to escort a Barracuda mission from launch to impact. The drone operates at 1,000 to 2,000 feet high enough to maintain line of sight with both the ground transmitter and the boat, and low enough to stay beneath Russian long-range air defense radar. Its relay system receives commands on the 5.8 gigahertz band from the ground station, then rebroadcasts them downward on a 2.4 gigahertz to the Barracuda at close range. 2 frequencies, 2 transmission paths, so jamming one doesn't automatically sever the other. But the chain is only as strong as its weakest link. Right now, that weak link was the Barracuda itself. The drone boat antenna sits just 10 inches above the waterline, the worst possible position for radio reception. Water reflects signals, reeds absorb them. The river surface scrambles transmissions into overlapping echoes that confuse the receiver. When Ukrainian jamming adds another layer of noise, the antenna can't separate commands from garbage. The operator watched his feed dissolve into blocky pixels. Latency, the delay between moving the joystick and the boat actually responding, jumped from 1/10 of a second to nearly half a second. At half a second of delay, the operator isn't controlling the boat in real time. He's guessing where it was a moment ago and hoping his inputs catch up. The Barracuda drifted 4 degrees off course. The FPV pilot reacted fast. He climbed another 200 feet and shifted 200 feet east, pulling the relay path above the worst jamming interference and realigning with the transmitter beam, and the signal punched through. Latency dropped back to 1/10 of a second. The video feed snapped crisp. The operator corrected course with 2 quick rudder taps. Friendly jamming was behind them. The relay chain had held, but ahead lies the wetland labyrinth, flooded forests, submerged debris, unmarked sandbars, and somewhere in the dark Russian eyes already searching for them. The Barracuda crossed into the flooded forest and the world went dark. Reed walls rose 15 feet on both sides, blocking any ambient light and turning the nose camera into a useless screen. The operator switched his focus entirely to the overhead feed, the FPV's thermal view looking straight down at the boat, threaded through a maze of vegetation, sandbars, and half-submerged debris. That's where the Matrice's thermal imager earned its place on the mission. At 640 by 512 resolution, the sensor could distinguish a submerged log from a sandbar by the temperature differential alone. Waterlogged wood holds heat longer than river silt. The 60 Hz refresh rate meant the FPV pilot saw obstacles in real time, not the half-second delayed slideshow a cheaper sensor would deliver. In a passage this narrow, half a second was the difference between threading a gap and burying the bow in debris. The Barracuda's electric motor pushed it forward at 6 knots, while the hull slithered between reed clusters like a snake, feeling its way through tall grass. At this speed, the boat moved just fast enough to maintain steerage, but slow enough to stop before hitting something the FPV spotted at the last second. Speed is the enemy in a flooded forest. A submerged log at 20 knots flips the boat or snaps the propeller shaft. A sandbar at 20 knots buries the hull in mud and ends the mission. The operator nudged the rudder. On the thermal feed, a faint white shape slid past the Barracuda's port side, a rusted barge hull half sunk and invisible from water level. If the boat had held its original heading, it would have scraped the wreck and possibly torn open the fiberglass. The channel narrowed further. Reeds pressed in until the passage was barely 10 feet wide. The Barracuda's wake rippled against vegetation on both sides. For 200 feet, the operator held his breath while the FPV pilot called out corrections in single-word bursts. Left steady, right steady. When the reeds opened up, the Barracuda emerged into a wider channel with actual current, deeper water, clearer sight lines, and room to maneuver. But the geometry had just changed in the worst possible way. Inside the flooded forest, 15-foot reed walls blocked line of sight from everything, including Russian observation drones. The Barracuda's thermal signature was visible to anything that wasn't directly overhead. Out here, the channel stretched 300 feet wide with low vegetation on both banks. The boat's heat bloom was now visible from half a mile in any direction. The FPV pilot saw it first, a faint white speck, moving laterally across the thermal display 2,000 feet to the northeast, then another circling in a slow orbit above the Russian bank. They weren't alone on this stretch of river, and the Russians were already hunting. On the thermal display, the white speck was no longer circling, it was diving. A Russian FPV attack drone dropping from 600 feet and accelerating directly toward the Barracuda's position. At typical FPV attack speeds of 70 miles per hour, the operator had roughly 8 seconds before the drone reached the boat. Reduce throttle, the pilot ordered drift to the reeds. Now, the operator cut power instantly. The Barracuda's momentum carried it toward a dense reed cluster on the right bank. While its thermal signature began cooling without the motor running, the boat slid into the vegetation and stopped, its hull hidden beneath the overhanging stalks. On thermal, the Barracuda was now just another warm shape among dozens of debris piles and mud banks. The Russian FPV screamed overhead at 50 feet, its camera hunting for the target it had spotted seconds ago. It circled once, twice, then climbed back toward its patrol altitude. Without a clear lock, the Russian pilot wasn't going to waste his drone on a guess. But the second Russian FPV was already repositioned, and this one knew where to look. The operator keyed his radio relay to Buaval Grid Reference 47 Quebec, Mike Delta bearing 045. Two hostile FPVs request immediate suppression. 14 miles behind the front line, a Buaval electronic warfare vehicle was already tracking the Russian drone activity. If you look at the vehicle, you'll see a modified tactical truck with multiple antenna panels mounted on a rotating turret. Those panels are phased array emitters that can focus jamming energy into a 30-degree cone and direct it at specific threat sectors. The Buaval operates across the 400 megahertz to 6 gigahertz frequency range, wide enough to cover every control link Russian FPV drones use, including the 900 megahertz, 1.2 gigahertz, and 2.4 gigahertz bands that are standard for commercial-based platforms. At full power, the system can sever a drone's control link from 10 kilometers away. But what makes Buaval truly dangerous is its precision. Older jammers flood the entire spectrum with noise, which blinds friendly drones as easily as enemy drones. But the Buaval uses digital radio frequency analysis to identify hostile signal characteristics, then generates targeted interference that attacks only those specific frequencies. The system can suppress Russian drones while leaving Ukrainian relay links untouched as long as the operators use different frequency bands. Tonight, the Buaval's turret rotated toward bearing 045, the antenna panels aligned, the system flooded the target sector with focused electromagnetic energy. On the FPV pilot's thermal display, the first Russian drone wobbled its control inputs going sluggish as the Buaval's jamming overwhelmed its receiver. 3 seconds later, it nosed over and dropped into the river. The second drone fared no better. Its pilot tried to climb out of the jamming cone, but the Buaval operator tracked the movement and kept the beam locked. The drone spiraled down and crashed into the reeds 400 feet from the Barracuda's hiding position. The operator waited 10 seconds, watching the thermal feed for any additional contacts. Nothing moved. The operator brought the throttle back up, the Barracuda slid out of the reeds and accelerated toward the final passage. Across 1,000 feet of open water sat the target, a cluster of Russian outboard boats, fuel drums stacked on wooden pallets, and makeshift supply shelters glowing white-hot on thermal. The sprint was about to begin, but the moment the Barracuda entered open water, the Russians hit back with their own electronic warfare, and this time they were aiming at the relay link itself. The video feed tore apart. One moment, the operator had a clean thermal picture of the target. The next, his screen was a mess of pixelated blocks and frozen frames. Latency spiked from 1/10 of a second to nearly half a second. Throttle commands stacked up instead of executing. The Barracuda's heading drifted 5 degrees right toward a reed bank, and the operator couldn't correct fast enough to stop it. This was Russian jamming. A vehicle-mounted Sea-Lock 01 electronic warfare system on the left bank had just come to life, flooding the river corridor with radio interference. The Sea-Lock isn't designed specifically to stop drone boats. It's designed to stop Ukrainian FPV attack drones and blind artillery spotters. But at water level, the interference hits surface vessels even harder. The problem is geometry. The Barracuda's antenna sits 10 inches above the waterline, the absolute worst position to receive a signal during jamming. Radio waves from the FPV relay are bouncing off the water, scattering through the reeds and getting drowned out by Russian noise. The FPV drone overhead is still receiving the bunker uplink clearly because it has altitude, but the connection from the FPV down to the Barracuda was collapsing. The operator understood exactly what was happening. The relay chain that kept the Barracuda alive bunker to transmitter to FPV to boat was being severed at its final link. The drone could still hear commands, the boat could not. The FPV pilot didn't wait for instructions. He climbed fast from 1,300 feet to 1,600 feet, then pushed 200 feet further east. Russian jammers broadcast their interference horizontally, focused on altitudes where Ukrainian drones typically operate. But jamming has blind spots directly above the antenna and at steep angles away from the broadcast axis. The signal strength drops by climbing and shifting position. The FPV pilot was hunting for a gap in the jamming bubble, a clean angle where the relay could punch through. For 8 seconds, the Barracuda was steering blind. The operator had no nose camera, no reliable telemetry, and no idea whether his inputs were reaching the boat. He switched to the FPV's overhead thermal view and steered purely by watching the Barracuda's white silhouette drift across the screen. Every rudder command was a guess, every throttle adjustment was a prayer. Then the FPV found the clean lane. At 1,800 feet altitude and 250 feet east of its original position, the relay path punched through the jamming, latency dropped back to 1/10 of a second, the video feed snapped crisp. The operator regained full control and corrected the Barracuda's heading with 3 quick rudder pulses. The jamming zone was behind them. The target was 700 feet ahead. Nothing stood between the Barracuda and the Russian logistics hub except open water. The sprint began. The Barracuda's throttle went to maximum, the electric motor surged, and the boat leapt forward at 38 knots, faster than any Russian soldier could react. On the FPV's thermal feed, the Barracuda's wake flared white-hot as the hull planed up and the bow sliced toward the target. The Russians saw it coming. On the riverbank, figures scrambled in different directions, some running for cover, others reaching for rifles. None of it mattered. At 38 knots, the Barracuda covered 100 feet every 1.6 seconds. By the time the first soldier raised his weapon, the boat was already inside 400 feet. By the time anyone could aim, it was inside 200. The operator locked the rudder on the center of the boat cluster. The FPV pilot called out the final distance. 300 feet, 200, 100. At 40 feet, the nose camera feed whited out from the glare of the approaching fuel drums. The operator released the controls. There was nothing left to do. The Barracuda's warhead was a shaped explosive charge designed to rupture thin-walled targets, aluminum boat hulls, steel fuel drums, wooden supply crates. On impact, the charge detonated outward and downward, converting the drone boat into a pressure wave that hit everything within 50 feet simultaneously. The first Russian outboard boat flipped completely out of the water. Its hull shattered before it splashed back down. A stack of fuel drums ruptured and ignited 1/10 of a second later, sending a pillar of fire 60 feet into the air. The blast wave rolled outward toward the bay, collapsing 2 supply shelters and scattering ammunition crates into the reeds. A second boat, still tied to the makeshift wooden dock, disintegrated into fiberglass splinters and spitting engine pumps. The FPV drone jolted upward as the pressure wave hit at 1,800 feet, then stabilized and held position. Its camera kept recording. Secondary explosions rippled through the debris for another 15 seconds, fuel puddles catching fire, ammunition cooking off something heavy, detonating inside one of the collapsed shelters. Burning wreckage spread across the shallow water, turning the bay into a floating inferno. Russian personnel fled inland, abandoning everything that wasn't already destroyed. When the smoke began to clear, the logistics hub was gone. The small boat staging area that had supported Russian raiding operations for months was now burning metal and shattered wood. Bye for now.